Do you ever wonder how magnificent architecture has become? Architecture is a simplistic yet complicated medium used to express creativity using mathematics and logical thinking.
Architecture has been a staple throughout history, from the pyramids and sphinxes in ancient Egypt to the Notre Dame and the Colosseum.
The foundation of any capital resource is architecture and engineering, and obviously, mathematics is an essential aspect of architecture which is constantly adapted.
The most textbook definition of geometry is the branch of mathematics concerned with the properties and relations of points, lines, surfaces, solids, and high-dimensional analogues.
Geometry refers to shapes, not only on paper but all around us. And when we take time to look at all the infrastructure, we can see many shapes, regular and irregular.
Architecture is using geometry in an artistic expression. This is evident as designing buildings is just a combination of regular and abstract shapes, lines and points.
If you were to think about how a house is designed on a 2D blueprint, it is a combination of uniform and irregular shapes that are measured.
We can find many aspects of geometry in architecture. In a blueprint, we use shapes, regular and irregular, as well as lines to form an outline of different rooms and buildings as accurately as possible. We also use connected dots and angles.
We use 2D shapes when designing a blueprint on a flat surface, such as paper or cardboard. Furthermore, due to the advancement in technology, we also use 3D shapes to create a scaled model of our designs, or use computers to simulate our design with 3D shapes.
Buildings, which are the result of architecture, also use many 2D and 3D shapes, lines, points, and angles to create aesthetically and eye-pleasing designs, as well as livable and effective spaces for recreation, living, business, education, and resources.
Now, we will delve into more specific equations, which are commonly used in architecture.
Pythagoras' theorem is an equation used to calculate the length of the hypotenuse by using other measured sides. For example, if the adjacent equaled 4 and the opposite equaled 3, by squaring both, we get the additional equation of 16 plus 9, which gives us a sum of 25. Since 25 equals the length of the hypotenuse squared, the hypotenuse is the square root of 25. Therefore, the hypotenuse has a length of 5. We use Pythagoras' theorem to figure out the hypotenuse of a triangle, which is a shape. Therefore, since geometry revolves around shapes and Pythagoras' theorem is an equation used for a triangle, Pythagoras' theorem is a geometrical equation/concept.
Next, can use the Pythagoras theorem to ensure that an angle is right. A common strategy to ensure that an angle in a corner, for example, is right, to use the 3, 4, 5 strategy. This is one architect measure one side to equal 3 and the other side to 4, and ensures that the hypotenuse is 5. Therefore making sure the angle is right. This is because if A and B equal to 3 and 4, this makes the hypotenuse 5 if the angle is right.
Architecture used the Pythagorean theorem to calculate the heights of buildings and the length of walls. The Pythagorean theorem is an equation many architects can use while designing famous buildings. If an architect is building a square structure, he or she can split the square into 2 triangles. If the architect knows 2 sides, then they can easily figure out the third side.
Perimeter is the distance around a 2D shape. Area is the space inside of a 2D shape.
The area and perimeter of a 2D shape is used in geometry since geometry revolves around measurement and the relation of angles, points, lines, which are all aspects of area and perimeter.
Different shapes require different formulas to figure out the area and perimeter. The picture provided shows the formula for area and perimeter of common shapes which are used in architecture. These shapes are the rectangle or square, a triangle, a circle, and a parallelogram. We also use many irregular shapes, but those do not have a set formula to figure out the area and perimeter of. To measure the area and perimeter of a blueprint and parts of a design, architects must know formulas for different shapes as they need to efficiently measure each part of the blueprint to convert it accurately. It is clear that without geometry, we would not be able to design infrastructure effectively and accurately. Without shapes, lines, angles, and points, which are all concepts of geometry, would architecture be possible?